So this is another fancy graph problem. This one is from 2018. It also is no calculator because it's problem number 5. So let's go ahead and try this one. And by the way, the reason I call it a fancy graph problem is because at the bottom there happens to be a fancy graph, whereas they're normally at the top. So let f be a function defined by, and so they actually are giving us the function f, and it looks like it's two functions connected by multiplication, right? First question, find the average rate of change of f on the interval 0 to pi. All right, so average rate of change is the question, and that's really just find the slope. Change of y over change of x. And so the interval, the change of x's, is just going to be pi. That's how far apart they are. And if I plug pi in, I'm going to get e to the pi cosine pi. And I'll have to figure out what that is in just a moment. And then I'm subtracting, right, y2 minus y1, subtracting e to the 0 cosine 0, right? So anything to the 0, e to the 0 is going to be 1. That's going to be a 1 right there. And cosine 0, let's go ahead and draw a little graph of cosine right over here. Graph of cosine is going to start at the top and it's going to go down like that. Right, so cosine of 0 is up high. That means this is going to be 1 also. That's a 1. E to the pi, I'm just going to leave it as e to the pi. And cosine pi. Pi is halfway, right? There's 2 pi. 1 pi is here, and that's going to be negative 1. So that's negative 1 right there. So my final answer is going to equal, let's see what we have. We have negative e to the pi, and here we have minus 1, all divided by pi. All right, change of y over change of x. Box up my answer. All right, next one. What is the slope of the line tangent to the graph of f at this x value? All right, so if I'm looking for the slope of a line, then I need the derivative, right? They gave me the actual function up here, so what I'm going to have to do to find the slope is take the derivative of this thing, so it looks like it's just a product rule problem. Derivative of e to the x is e to the x with cosine written. And then add, and the derivative of cosine x is, and of course I can't remember anything, so I'm going to write sine, cosine, negative cosine. Like I said, the derivative of cosine x is negative sine x. So I'm going to say negative sine x with e to the x just written right there also. This is the derivative, so I could write f prime, what is the slope? And it looks like I need to plug in that value now. So I'm going to have e to the 3 pi over 2 cosine 3 pi over 2, and I'll figure out what the value that is in just a moment, minus sine to the 3 pi over 2 with e to the 3 pi over 2. All right, so we need to figure out what cosine and sine of 3 pi over 2 is. This time I'm going to think about it like a unit circle. So if I had the unit circle right here, 3 pi over 2 is going to be not 1 pi, not 2 pi's, but 3 pi's over 2. It's going to be facing right down here, and that coordinate would be 0, negative 1. So it looks like the answer for cosine is 0. So that's zeroed out, which means this whole thing is gone. And sine is negative 1, so this is going to be negative 1 right there. So we have a negative 1, which is going to equal positive 1 times e to the 3 pi over 2. That's the slope at that value. Okay? And part C. Find the absolute minimum value of f on the interval 0 to 2 pi and justify my answer. Okay, so I feel like I remember on 2019 they asked a problem that was extremely similar. To find a minimum, first thing we're going to have to do is take the derivative. Well, minimums occur at endpoints or when the derivative is equal to 0 or undefined. So endpoints is one place I want to look. I'm going to make a little chart right here. Endpoints, the x values can be 0 or 2 pi. I just need to figure out if there's anywhere along the way as well. So looks like I already have the derivative of this thing, so I'm going to use that. F prime is equal to, and I'm going to rewrite rewrite it just a little bit to make it a little bit nicer. E to the x cosine x minus e to the x sine x. And I want to know, when is this thing going to equal 0? Unfortunately, I'm not allowed to use a calculator, so I have to be clever. How can I figure out when this thing is equal to 0 to find out if there are any other values of x I need to look at? So looking at this thing, I have two terms. Let me throw an x in there. I have two terms, and they both have a e to the x in common. E to the x. So what's left in this term? It's going to be cosine x, and what's left in this term? Minus sine x equals 0. What's nice about that is, when is e to the x ever going to equal 0? Never, right? So all we really have to focus on is, when is cosine x minus sine x equal to 0? And so when would they equal 0? It would be when they are exactly the same. When cosine and sine are exactly the same, it would equal 0. So when are cosine and sine equal the same? If I put a little unit circle right here, cosine and sine would be the same when they are angle bisectors, I think, square root 2's over 2's. So right up here on the unit circle, they would both be square root 2 over 2. And also there they would be different signs. All students take. Here's the other spot. They would be negative square root 2's over 2's. So that's going to be pi over 4. And that's 1/4, 2/4, 3/4, 4/4. This is 5 pi over 4. So here they're both square root 2 over 2. And here they're both negative square root 2 over 2. So those are the two other x values I want to look at. That was pi over 4 and also 5 pi over 4. So hopefully a couple of these, when we plug them in, are going to be pretty easy. We'll see. We're trying to minimize the value of f. And so f is right here. So I'm really just plugging into this guy. So I have e to the 0, because I'm plugging in 0 to start. E to the 0, and then I have cosine 0. And I'm just going to plug in. We'll figure out what the values of them are later. But this is just going to be 1 and cosine 0. Cosine starts at 1, so I think this is 1 times 1. But we'll figure out the value in a moment. Value. We are looking for a minimum. So. All right, pi over 4. So we have e to the pi over 4, cosine pi over 4. And then we have e to the 5 pi over 4, cosine 5 pi over 4. And last one, we have e to the 2 pi cosine 2 pi. All right, so looks like we're looking at cosine for all of these, which is our x value on our graph over here, or on our unit circle. So cosine of 0. Cosine of 0, like I said, is 1, 0, which means cosine is going to be 1. So this is 1 times 1, which is 1. Could that be the lowest value? Possibly. All right, next one is some number times cosine pi over 4. And we already said pi over 4 was an answer of square root 2 over 2. So equals some number. It's going to be e to the pi over 4 times square root 2 over 2. That looks pretty ugly. I have no idea what that value is. But hopefully one of them is going to be obvious, like I said, along the way. All right, next one. E to the 5 pi over 4. E to the 5 pi over 4. And then cosine 5 pi over 4 is, it's over here, all students take. So this has to be negative square root 2 over 2. And I'm hoping that's the answer. Let me just finish up with the last one. Cosine of 2 pi. Cosine of 2 pi is going to be right back around here, which is 1. So this is just e to the 2 pi. So which one's the lowest value? The positive values or the negative answer? Negative answer has to be the smallest value. So the question, let's just make sure we answered it. Find the absolute minimum value. And the minimum value I boxed up right there. E to the 5 pi over 4 times negative square root 2 over 2. Because it's the only negative value. All right, last one. Let G. And once again, this is one of those things that they like to do at the very end of the problem. They like to introduce a new function, G, Where did g come from? They needed another question apparently. So let g be a differentiable function. So this means we could do all kinds of things with theorems. We could integrate, take the derivative, we have mean value theorem, intermediate value theorem, all kinds of stuff. Let g be a differentiable function such that g of pi over 2 equals 0, an initial condition. Find the graph of g prime. The derivative of g is shown below. Find the value of the limit as x goes to pi over 2 for f of x over g of x, or state that it does not exist. Okay, so basically the first thing I think when I see that is, just at least in the back of my head, L'Hopital's rule. May it happen? Last time it didn't happen. I was thinking it was, but it didn't. Maybe this time it will. I need to find f of pi over 2. Plug it in, see what happens. And also g of pi over 2. See if there is any issue at all. F of pi over 2. That's our original function, right up there. Have I already done this somewhere? I'm not exactly sure. I've just been rattling along. F of pi over 2. I'm going to go ahead and plug it in right now. So we have e to pi over 2 and then cosine pi over 2 over, and here we have to plug in, sorry you couldn't see that, I just plugged in pi over 2 into our original function that was right there. And for g, I'm going to go ahead and plug in pi over 2, but this is a graph of g prime. And that's why they gave me this extra little piece of information. That is 0. So I'm kind of hoping at this point, because that's 0, that the top is 0, so I could use L'Hopital's rule. Let's see if this is 0. I know that one's not going to be 0, but is this cosine of pi over 2? I have this coordinate plane over here already. Pi over 2 is right here, and the coordinate there is 0, 1, which means the answer for cosine is 0. So that is 0, which makes it a L'Hopital's rule problem. Well, hopefully. Let's see if it works. The derivative of f is f prime. And the derivative of g is g prime. Right? And we still just plug in the pi over 2. So pi over 2 gets plugged in here, and pi over 2 gets plugged in there. I think the derivative is going to be a little bit easier on the bottom because we have a graph of it. So what's the value for g prime when we plug in pi over 2? It looks like it's going to be a y value of 2. And in the numerator, we have our derivative that we have to plug pi over 2 into. And I know that I've already taken the derivative. I wrote it right here. Right? The derivative is equal to that guy. So I need to plug in pi over 2 into that thing right there. Let me see if I can do it. We have e to the, plugging in pi over 2, cosine pi over 2, and then minus e to the pi over 2 sine pi over 2. And I believe one of these, wasn't one of them already 0? It looks like cosine was already 0, right? So this denominator, I just plugged in pi over 2 into that derivative, and I already know that cosine was going to be 0, so that whole thing is gone. And I'm left with the final answer of negative e to the pi over 2 sine pi over 2, all divided by 2. And I could find out what that value is, but this answer should be correct, so I'm going to go ahead and leave it there.